So when I thought about what to speak about today, I really wanted to really follow the theme here. I'm going to talk a little bit more about the specific technologies, but in every major shift that occurs, it is always going to be disruptive. And actually, there's some of the most annoying things for me that have occurred, which are always going to occur, which is people are going to jump on certain bandwagons and try and put their own slant on what the big data world is about. And I agree that there is no great definition for single definition for big data. And I actually think the origins of big data have been lost. And I want to kind of I'm going to try and do a bit of history, a bit of technology, and a bit of learning on if you're getting into this area, both either as trying to adopt big data or understanding of the value you can get out of big data. So I'm going to quickly, for 30 seconds, cover what I do just to put myself in context of this. So we work in the world of social. We have a stupid amount of data we process. We store huge amounts. And we have a massive cluster dealing with all of this data. Well, that just puts us in context. It's a very specialized world that my company lives in. And I want to put that in context of, even though we would be definitely classed as a big data problem, why it doesn't apply to everyone. So the myths and legends. So interestingly, in relation to what Kenneth talked about here, I thought I would ask Google what people thought. I don't know if many people here use this, but always writing something and say "is" on Google is great, because Google, again, uses big data to analyze all this data and understand predictively what you're going to search for. So it's a great way of actually understanding what people think about it. And these are the results. You can do it now. And actually, when I did this search, I actually used it as the kind of the theme of some of the subject areas to talk through. So, big data is bullshit, I think is great. And it's attached to what the vendors are doing out there. And look, they're out there trying to sell their stuff. That's what they do. And there's a whole range of areas in which they're trying to reposition themselves so that they don't get washed away basically by this. So, and what I think what they're doing is the usual FUD, is fear, uncertainty, and the myths around this start with hardware. And I'll talk more on why this is a context problem, but just think back. So big data has spawned a whole load of technologies, and many of them have been open sourced. So that basically means for any of you don't understand the kind of the open source environment. When people write white papers on a whole range of data processing subjects, and people then adopt those and build open source projects around them. And one of the it's probably impossible to go near a computer now and not find the word Hadoop and big data said in the same paragraph at least 20 times. And Hadoop scared the hell out of the vendors because it was free suddenly. It had been designed by Google. The background of Hadoop. Their Google file system and MapReduce were invented. The original white papers were invented by Google. And the vendors didn't like that because suddenly they're going, well, we're out there selling all of this huge amounts of these database systems. I'm not going to talk about any particular vendors. They're all the same to blame for the propensity of this. And they are out there basically saying, you now need to buy all of this hardware. And they want you to buy specialized hardware. Whereas actually the reality of Hadoop especially is, if you talk to anyone who's practically using Hadoop, is it runs on what Google really invented, the idea of commodity hardware, which is you only need hardware that has got a short lifespan. And if it breaks, you just throw it away, literally throw it away. In fact, our data center, if something breaks within our cluster, is literally no point using it again. It's cheaper just to replace it and move on. But actually what they want to do is sell you the most expensive hardware with the most high reliability and all of the et cetera. So that's number one myth for me, is they want you to buy all of this, but you don't need to. Number two is, and this is very much in line as well, Ken, is that the size of the data. So I'm going to take you through some of the examples of size who are really big data companies. So we obviously know Google has silly amounts of data. Recently, the last couple of years, they've not been publishing much. So this is the most recent data I could find, which was their search index is 20 petabytes. So that's just one small part of Google, and they're nearly at 1 million servers. So, they are, without doubt, they invented a lot of this. They're a big data company. Facebook, 1 billion users now, generates 3.2 billion likes and comments every day, and, a part of my business is looking at some of this data, and over half a petabyte every 24 hours. That is silly amounts of data. Facebook have also adopted a lot of these technologies. If you read any of their developer blogs, they are also committing a lot of their open source software. And then the Large Hadron Collider. By the way, I always think when I look at this that Jean-Luc Picard should be somewhere in there as a Borg. The 150 million sensors, this is silly amounts of data. I actually checked this yesterday. They are up to something like 200 petabytes of data they've collected in the last 3 years alone. But what about an actual typical company? So this is where the disconnect for me is. There's a difference between companies that are producing software on behalf of people, and there's actually where the companies, individual smaller companies, need big data. And there's a number of factors here about what people actually need. But I just made these up. I did a whole load of research. It's very hard to find typical data sizes within companies, but I actually asked a couple. We're in an enterprise center, so I went around and asked a couple of these larger companies. So let's say you've got 100 employees, 10,000 customers, and you have 25 databases within your company, and that can be customer records, transaction stuff. It can be all of your employee data. You're tracking your internal web traffic data, whatever it is, you track all of it. Let's say you've got 1 million transaction records, 5,000 bytes, characters, and that adds up to about 4 gigabytes. Let's say, be really generous and say they've got a lot of extra data, and the total for all of their databases is 20 gigabytes. Now, a typical hard drive, if you go on Amazon, the average is about 2 terabytes. And you can actually now buy a 4 terabyte drive. One drive, and a whole company can fit in it hundreds of times. So why are we trying to sell people hundreds of servers? Just because that's their job. But the reality is 99.9% of businesses can fit nearly all of their data on one hard drive these days. But actually that misses the point of what big data was actually all about. So I'm going to come back to that and talk about a third myth, which is you have to have lots of Dilberts, lots of data scientists working on your data. So we actually have data scientists in our company, but I'm very anti this whole idea of preaching that the world suddenly needs millions of new data scientists. So it's suddenly become a area where this title didn't exist. I don't know how long ago, but it suddenly turned into this mythical beast who must be creative, must have done maths and preferably programming, because there's a whole load of languages involved in data science, and that to get the value out of data, you have to have a whole bunch of these, or hire them from some other firm, obviously, at exorbitant rates. And the reality is, this is actually what most companies use, or an equivalent. the very large amount of the world's crunching of data happens inside Excel. It's sad, but it's true. That's one of Microsoft's cash cows. And what I think is wrong is that the idea that to get the data we want out requires all this data science misses the point that most companies want simple answers. They want yes, no answers out of their data. And this very much comes about to Ken said, it's about correlations. You actually want to hide the data science. You want programs that do the processing that then give you the simple answers. So a great example is why we all, and I'm sure a number of you use LinkedIn. LinkedIn is a great example of a big data company. They have vast amount of data about who we are, who we're connected to, and they obviously do huge amounts of data mining, but they balance that between how they make our lives easier by trying to find connections in particular areas. They can suggest connections because they understand what network you're connected to, and they can look at that and they can understand who else they think you should be connected to, and then they can obviously use that to do targeting. But they are making that very simple for you. By the way, LinkedIn also has a number of fantastic open source projects that we actually use a number of them. But the reality is what most people want is to go into Excel and plug their data in and get answers out the other end. The other really interesting facet, when there's a couple of studies, and they don't tend to get much coverage. So this was a Gartner chart. I'm not going into huge detail, but it talks about banking, communications, and government. And the red bits are what are the hot areas in big data. So they basically make, Gartner's job to work out where all these billions are going to get spent in them. But actually, this was a survey done of asking people what they are doing with big data. What's the practicalities of what's ended up? And the actual reality is, and it's quite sad, and what I want to change, part of, about this is, so 51% of respondents to this, it was quite a big survey, 51% of the people surveyed who said they were using a big data solution said they were putting just their weblog data into it, and the other was their clickstream data. So that's a huge amount. So, that's 85% of the respondents said most of their use case was just taking basic, simple, and most clickstream data and log data is structured. It's line by line, and the reason they've migrated to it is because those data sets are large. They do, these days the amount of web traffic trying to fit all your web logs into one machine is difficult. So that's the market is very much comes to that. And I talked to most of the Hadoop vendors, and they all said the same thing. 90% of their business is processing this, and actually that to me is quite sad because the value of what you can do is so much more with the processing. So I'm gonna talk about what you can do with Hadoop and what the actual platform was designed for. So this was my step, which is because the vendors don't want their current businesses destroyed, they are plugging whatever the hell they can into Hadoop. They don't care what it is. If they already had it in their catalog, they want to plug it in. And this is the worst one ever. So if any of you know anything about SQL, SQL is just a query language, and it sits on top of the top 3 databases in the world: Oracle, SQL Server, Microsoft, and open source MySQL. But MySQL is designed to live in this world. This is a schema of a database. So every table in the database has a fixed structure with a number of fields in it, and this is a fully normalized data set, i.e. it means that each table points at other data sets. So if you have a user record and that user has a number of transactions, that is a separate table. So the thing about relational databases, they need to be predefined. They need the indexes to be perform. So an index is, for the not technical among you, is basically if you've got lots of records and you need to find one particular record quickly, the index allows finding that fast by a particular field within that record. But they have to be predefined. And the more indexes you have, the slower the database, and that's what database architects get paid lots of money to do. The queries are then constrained. So we're coming back to SQL here. The problem with SQL is that your definition of your database constrains what you can ask it. So you build it, and you build a customer record database, and it's designed so you can find the customers. You go onto the website, and you type in your username. The SQL is out there going, look for that username, look for that password, where's that record, can they log in? That's a very simplistic looking at SQL. But even complex queries only allow you to perform things that you designed right at the beginning. It's crucial to all database design is you must know what you want to do at the beginning. I'm not going to talk through this diagram. This is the diagram, a diagram, there's lots of diagrams, of how MapReduce works. But let me talk you through what the key fundamentals are. Number one, this is designed to be distributed so that if you have large data sets, you can process the data across a number of computers and that you can run this in parallel. But I think the most important aspect is it doesn't matter the kind of analysis of what you want to do with the data. The question you ask of the data set does not need to be predefined. Literally, you can bring any disparate data set together. And this is where, just rolling back to what I said at the beginning, one of the real losses of the beginnings of big data was that it was about the joining of data sets. It wasn't about the size of them. It got tagged on this idea that they had to be huge was because if you take more than one data set together, it must be big. But actually, the reality is and you know, say there's plenty of use cases that are large, but the fundamentally here is that Hadoop and other systems like it are about being able to process a data set without the constraints of a fixed schema, so that if you are a data scientist, if you want to do analysis, you can do it without having to pre-plan it right at the beginning. So this is actually, again, I'm not going to talk through these, but these are things you can do with a big data schema, in that they tend to be what they call column-based, which is you just have like an Excel sheet, but you have no restriction on the number of columns. You know, you go to A to Z, and then you go AZ to, you know, you're going to have thousands of columns with lots and lots of different disparate records with sparse data in them, and you can mix them together. So this is a good example here. The top one here, this is records, but you can see each record is actually a completely different data set, and you can mix them all together. But when you actually read them, it means you can process them as a whole. You can perform your joins on the fly. You can aggregate the data however you want, and the systems tend to work on files and columns, you know, whatever else you want. But that's the point that I think we're losing, and why most of the use cases have been focused too much on the scale and not on the value. Quick aside, by the way, how many people are programmers here? Hands up. Oh, quite a lot. So if any of you want to start using HBase, don't. Those are the top response about HBase. We used it for a year. Don't touch it with a barge pole. So that was quick aside. So, well, Cassandra is actually way better. Cassandra is actually something that Facebook invented a year and a half ago. It wasn't very mature, but in terms of competitiveness with HBase, it's miles ahead now. So come back to this whole thing that Google, what we have to remember here, and the vendors have to remember, is this all started quite a few years ago with Google. And then they haven't stopped. This is the scary thing for them. You know, they started these papers, and it took a while for Doug Cutting and other people who invented Hadoop. Google haven't stopped. So, they released Google Dremel. This is actually another white paper they released. It is very different to your standard Hadoop distribution in that it is SQL compliant, but it's meant to be designed for doing relational operations, but at massive scales. So you can perform interactive analysis, and it scales up to tens of thousands of servers, and it allows the data still to be stored as columns. But what was great, Google did the same thing. They released a commercial product called Google BigQuery, but then they worked with the Apache Foundation, it became Open Dremel, and then it became Apache Drill. So that's actually already out there, and that's going to have a huge impact down the road, because it's suddenly going to be, at the moment, we're in this, still in a bit of the hype cycle, but what we've got to remember is that the innovation hasn't stopped. And I think too much focus, and again to the developers here, too much focus has been put on one technology that, as far as the cutting edge people is concerned, is already dead. And this got some attention when it came out. So Google has got to such scale that they don't talk about multiple hard drives or multiple racks of servers or even a single data set. They now think about how do you scale your database across the world. And this was they haven't given huge detail behind this, but I thought I'd just quickly touch upon it because I thought it was fascinating. They've designed a database that scales globally, but is accessed, you can access it, and it deals with the scalability of across time zones. And actually some of the innovation around was it is still a traditional relational database, so it's very easy to do structured data within it. It's globally distributed, and they actually invented their own way of synchronizing timing of data. Now, why that's important is because of atomicness. It's about, if you write a record to a database, you've got to know which one got written first. So they actually threw away what everyone else had been using, basically invented this ability to use GPS and their own idea of, they've got their own atomic clocks and this idea of true time. Right now, there's no open source equivalent. That's the scary thing. So they're out there doing this so many years ahead of us, and we are miles away of being close to what they are doing. And that's why, I want there to be more effort in not being the vendors focusing us on just a technology that is old, and I want us to move forward and be able to compete with the one player that's actually blazing a trail here. But overall, I think the last point on here is the new oil. So big data is, whatever the hype cycle, the value is there, even if you discount the hype and the mis-selling of how you should do it, it's open source, the tools are there to use it, and the value is definitely there to use it. So, go out there and use it. Thank you very much.